Greetings, I'm Dev the developer.
And I'm Glitch.
We spent the last few videos building a payroll system where polymorphism does all the heavy lifting. Call a method on any employee reference and the right behavior kicks in automatically. Today, we're going to look at the cases where that stops being enough. Some operations are genuinely specific to one type, and you have to know what you're actually working with. We'll look at the tools C# gives you for that, when to use them, and just as importantly, when they're a warning sign that something's gone wrong. So, here's the situation. Our app handles a pay command. It loops through the employee list, calls calculate pay on each one, and the right thing happens automatically for every type. That's polymorphism working exactly as intended. Now, I want to add a work command. The idea, someone types work 18 and the app logs 8 hours for employee number 1.
Easy, I'll just add a log hours method to the base employee class and override it in hourly employee. Same pattern as calculate pay.
What would log hours do on a salaried employee?
I mean, nothing, it doesn't apply to them, but I could just leave it empty on the types where it doesn't make sense.
And what does the app tell the user when they type work 18 for employee 1 and employee 1 turns out to be a salaried manager?
Nothing, it just silently succeeds. The user would have no idea the command didn't actually do anything.
Right, the user made a mistake and the app pretended it was fine. That's a bad outcome. We want to tell them that they made a mistake, but a base class method that does nothing on some types can't even distinguish between success and a quiet lie.
So the real problem isn't the implementation. It's that log hours doesn't belong on the base class at all. It's not a thing every employee does differently. It's a thing only hourly employees do, period.
That's the distinction. Polymorphism is a right tool when every type does the same operation, just differently. Calculate pay is on every employee. Get report is on every employee. But logging hours is not a base class concept. It only makes sense for one specific type. And for operations like that, we need to know what we're actually working with at runtime.
So we need to look through the employee reference and see the real concrete type underneath.
Exactly. And C# has a clean way to do that. Let's build the work command handler together. Before we write the work command handler, we need a utility. Every command is going to start the same way. Look up an employee by their ID, add a find employee helper.
It walks the list, returns the match if it finds one, and returns null if nothing matched.
Good. We'll handle the null case properly when we cover error handling. For now, we know that we're only calling this with IDs that exist. Now add handle work below it.
Okay, so first I find the right employee using find employee.
Good. Now we have a specific employee reference. We know something is there, but we don't know what specific type it is yet. Here's the key line. Read that out loud slowly.
If employee is hourly, employee hourly. Wait, what's that second hourly doing there?
That's the variable name you're declaring. That one expression does two things at once. It tests whether the employee is actually an hourly employee at runtime, and if the test passes, it creates a new variable named hourly, typed as hourly employee, pointing to the same object. Inside the if block, hourly is available and fully typed.
So the check and the cast are the same line. I don't have to check, then separately cast in a second step. It's one expression.
Right, and hourly only exists inside the if block. The compiler scopes it there on purpose because outside the block the test did not pass and the variable wouldn't be valid anyway.
That's actually a really good default. You can't accidentally use the typed variable in a place where you don't know the type is right.
That's the whole design. Finish the method. Look at else. We're calling name and get title on employee. the base class reference. Those exist on every employee type, so we can give the user a clear specific error message without knowing anything about which specific wrong type they sent.
So a salaried employee, a manager, anyone who isn't hourly, they all hit the else and get cannot log hours for Alice salaried employee, something actually useful.
Not silent nothing. Now, let's do the same thing for managers. Only a manager can receive a discretionary bonus, and only through the handle bonus command. Add it.
Same shape, different type. I've got this one.
Good. Same pattern. You've seen it once. It reads naturally the second time.
Wait, so what happens if I accidentally call handle bonus with an hourly employee, like if I wired up the commands wrong?
Walk through it. What does employee is manager evaluate to?
False, because it's an hourly employee, not a manager, so it hits the else, and the user gets cannot apply a bonus to Bob hourly employee.
The wrong handler doesn't crash. It just gives the correct feedback for the wrong situation. That's a nice property to have.
Okay, now I want to ask something. We've been talking about when to type check, but when do you not type checks? Like, what does the wrong version look like?
Let me show you. What if instead of using calculate pay polymorphically, someone wrote the pay command handler like this?
I mean, it produces the right number, right?
It does. Now tell me what happens when we add a new employee type, say an intern employee.
I'd have to find this block and add another else if for it.
And how many places in the codebase have that chain?
However many times I was lazy enough to write it instead of using the virtual method.
Versus a polymorphic version where you add intern employee, override calculate pay, and every loop in the entire app automatically handles it correctly. Zero changes to existing code. The type checking version is fragile. It requires you to find and update every branch every time the type hierarchy changes. That's exactly the kind of maintenance problem polymorphism was designed to eliminate.
So the sign of a problem is writing the same is type A, is type B, is type C chain for an operation that all the types share. If they all share it, it should be virtual or abstract on the base class.
That's the test. Type checking is a right tool when the operation is genuinely specific to one type. Work only applies to hourly employees. Sale only applies to commission employees. Those don't belong on the same base class. If you're type checking to compute something that every employee computes anyway, you've just reinvented polymorphism the bad way.
So if the operation is specific to one type, you type check. If all the types share it, you use a virtual override.
Now, there's another operator you'll see in existing code. It's called as. Let me show you what it does because you'll encounter it.
As tries the cast and gives back either the typed object or null. Then you check for null before using it.
Two separate steps. The cast attempt, then the null check. What's the risk if you forget the null check?
You calls log hours on null and the program crashes at runtime, and the compiler won't warn you. It can't tell from the type alone whether hourly might be null.
Exactly. That's the trap. With the is type pattern, hourly only exists inside of the if block. The variable is scoped to the place where the type check already passed. You can't use it in a place where it might be null because it doesn't exist outside of the check. We'll cover full null handling in a future video. For now, prefer the is pattern. You sidestep the problem entirely.
Got it. Is pattern is the default. As is something to recognize when reading other people's code.
Now, there's a scenario where the if is pattern starts getting repetitive. What if you want to produce a different description string for every employee type? Not one type versus everyone else, but every type gets its own specific output.
I'd write a chain of else if statements. One for hourly employee, one for salaried employee, one for manager.
Try it. Let's see what that actually looks like.
Okay, that works, but it's a lot of else if, and I have to declare description separately up top because each branch assigns to it.
Notice the order. Manager comes before salaried employee. Why?
Oh, because a manager is a salaried employee. If salaried employee came first, it would match managers too, and the manager arm would never run.
Right. More specific types go first. The first arm that matches wins. Keep that rule in your head for the switch expression version 2. It works, and there's a cleaner form for exactly this situation. A switch expression with type patterns.
A switch expression like the ones we used earlier in the series for value matching, but for types.
Same idea. A switch expression evaluates to a single value. Each arm tests something and produces a result. We just use type patterns as what we're testing.
Let me rewrite it.
Same logic, much tighter. What's the underscore at the bottom?
The discard, it's the default arm, matches anything that didn't match a previous arm. Without it, the compiler warns you about unhandled cases.
Right. It's the default equivalent for switch expressions. And notice each arm. You write the type, optionally declare a variable like H or S, and then use that typed variable on the right side of the fat arrow. The entire expression evaluates to one string that gets assigned to description. Declaration and assignment in one expression, instead of declare then assign in 2.
And if I wanted to pass it directly to console.writeLine instead of storing it, I could just use the switch expression inline.
You could, though at this level of complexity, keeping the assignment separate makes it a little easier to read.
And with dev, there's something interesting about this whole lesson that I keep thinking about.
Go ahead.
So we've got all these employees stored as employee references. The polymorphism works because the runtime object is still the actual concrete type even when you're holding it through a base class reference. The is operator goes past the declared type and looks at what the object actually is underneath. It sees the real identity, not just the interface or the base class that's being presented. That's genuinely useful for a certain class of problems, like imagine you have a list of iService references. Every node presents the same interface, but some of them are actually coordinator node instances with elevated permissions and some are just pass-through relay instances. If you needed to identify which nodes could receive phase 1 directives before initiating a propagation sequence across all active relays simultaneously.
Glitch.
I mean, for network diagnostics, that is the use case I'm describing. It is a very standard enterprise architecture scenario.
What you're describing about the runtime is real and worth holding on to. Every object has 2 views of its type. There's the declared type of the variable that's holding it, which is what the compiler reasons about. And there's the runtime type, what the object actually is when the program runs. Polymorphism works because the runtime type derives method dispatch. And is works because it asks the object directly what it actually is, not what the variable holding says it is.
So when we write employee is hourly, employee hourly, we're asking the object itself what it is, not the employee variable.
That's a good way to put it. And that's why type checking is powerful for the right cases and why overusing it is a sign of trouble. You're deliberately stepping outside of abstraction. That should be intentional, not a habit. One more thing before we close out. We've been building the whole payroll hierarchy with inheritance, but there's a second design option that you should know exists.
What's the second option?
Composition. Instead of manager inheriting from salaried employee, a manager class could hold a salaried employee as a field and delegate to it.
Like a manager has a salaried employee inside it instead of being one.
Exactly. Has a instead of a is a. Let me show you the difference.
So manager isn't extending anything. It holds a salaried employee inside and calls its calculate pay to get the salary part, then adds the bonus on top.
That works for code reuse, but there's a real trade-off. What list can you put this manager in?
Just a list of manager, not a list of employee.
Because
Because it doesn't inherit from employee, so the compiler doesn't consider it an employee type. It just borrows some behavior from one. It's not the same thing as being one.
that's the whole thing. Inheritance gives you type identity. A composed manager is not an employee to the type system. You can't use it anywhere an employee is expected. So when you're deciding between the two, the question is, do you need polymorphism? Do you need this type to be usable where the base type is used? If yes, inheritance. If you just need to reuse some behavior without caring about the type relationship, composition is often the cleaner choice.
So if the relationship is A, you use inheritance. If it's has A, you consider composition instead.
Solid rule of thumb.
It's kind of funny that the is operator in C number lines up with the is a relationship. Like even the syntax is reminding you which relationship is which.
The language designers were thinking about this. So here's where we've landed. Some operations genuinely require knowledge of what a type actually is. The work command only makes sense for hourly employees. A discretionary bonus only makes sense for managers. For those, the is type pattern is your tool. One expression that checks the type and gives you a typed variable scope to the block where the check's passed. Use as when you encounter it in existing code and understand why it requires a null check. Use a switch expression with the type patterns when you need different output for each type and want the whole thing to evaluate to a single value. And remember, when types share a base, more specific types go first or a more general arm swallows them. If you ever find yourself writing is type A, is type B, is type C for an operation that all the types share, stop. The operation belongs on the base class. The goal is always to let the type system do the work when it can and reach for the type checking deliberately when it genuinely can't. Write the work and bonus handlers yourself. Add a new employee type to your hierarchy and see which code breaks and which code doesn't have to change at all. That's where this really lands. Don't just watch it, do it.